We will be creating a complete shooting mechanic, including an ammunition system, reloading, damaging and interacting with physics objects, adding some visuals like muzzle flash and bullet holes. We will also add some sound effects and fix problems like a gun clipping into a wall. In the end, we will improve the shooting mechanic by adding recoil and spray features. Let's dive right into it.
Here we have a basic project setup already. Right now you can only move around and interact with objects. We have all the assets needed for this tutorial created in advance. And you can download this project from GitHub, set it up in Godot, and follow me as I add features one by one. The link is in the description. First, we are going to shoot a ray from the player camera and check if it hits something. For this, create a script called gun and attach it to the gun scene. Let's open the script and start coding the logic. Delete these functions and add a class name gun because the script is called gun. This step is not necessary, but I always add class names for consistency. Currently, we only need a variable for maximum shooting range and a reference to the player camera. Let's add them. Export means that a variable can be set from the inspector like this, and onReady means that the reference will be automatically assigned during the initial loading process of the game. Now add a function that will handle shooting. We want this function to be called whenever we click a button. For this, go to Project Settings, Inputs, and add a new action called Shoot. Assign a shooting button and add a code that goes like this. Call the shoot function whenever the shoot action is just clicked. For the shooting to work, we need to define a space state. We also need the starting position of the ray we are going to shoot, which will simply be the global position of the player camera. Now, we will calculate the end position of the desired ray using a ray direction, which simply is a direction of the player camera. The only thing left is to get a result. Let's add the print function and check if it works. Bang, bang, bang. The console says that we hit an enemy, a crate, and then it's empty because we shoot in the sky. Awesome! Also, don't forget to select the gun scene and set the shooting range variable from the inspector, otherwise it will be 0 and you won't hit anything. Realistically, a gun magazine can hold only a limited amount of ammo, and when it gets empty, the gun reloads. Let's implement that logic. We will need a couple of variables for this. 3 of them will be set from the inspector, and we will modify these variables only within this script. First, reset the ammo variables while loading the game, and create 2 new functions, one for removing a bullet and the other for reloading. Here, we reduce the ammo count by 1, and when the magazine gets empty, we reload. In order to update the UI, we need 2 additional scripts. The global signals script will be used as an autoload to hold a signal called ammo updated. We will emit it right here. Don't add a class name to autoload scripts, or you cannot add them like this. The canvas script, the second new script, will start listening to the ammo updated signal, and whenever it gets emitted, the canvas script will update the UI. How elegant this is. For the reload function, we set the boolean to true, update the ammo count, wait for a while, emit the signal, and finish reloading. Let's remove a bullet after we shoot and check if it works. We shoot, the ammo count gets reduced, and when the magazine gets empty, the gun reloads. Awesome! Here we have a minor issue. The problem is that we can still shoot while reloading, but the fix is easy. Just check if we can shoot. Currently, when we click, the gun only shoots once, but we want it to be automatic. For this to work, we will need 2 more variables. Let's set the shoot delay to 0.1 and modify the shoot function. We will need a delta variable here, and we want to continuously shoot as long as we click the button. For the shooting to be automatic, we start adding up delta, which is the time between frames, until it reaches the shoot delay. Then we shoot, reset, and repeat. One more thing, these 2 lines will make sure that when we start shooting, there is no initial delay. Now let's test it, and you can see everything works as intended. Awesome! As you can see, the gun cannot deal any damage. Let's fix that. We want enemies to die and crates to get destroyed. For this purpose, we will need 2 components, a damageable script and an impactable script. The damageable script will extend the node 3D. We will use 2 health variables. On ready, we will initialize the health, and the other scripts can call this function, dealing some damage. When the health goes 0, the object dies. The impactable script will extend the damageable one. We also need to define a root node, which must be a rigid body 3D unless
else it won't work. Here we have only one function that the other scripts can call to deal some damage and also impact the object. Now that we have these components set up, we also need to create 3 new scripts for each damageable object. That will be for a crate part, and an enemy. A crate will be impactable with some additional logic to spawn crate parts when it gets destroyed. This is the scene that gets spawned. A crate part will also be impactable with no additional logic, and an enemy will be damageable. You will probably want to add some additional AI logic here for your own projects. Let's add these 3 scripts to the respectable scenes and set the max health variable for each of them. We want crate parts to be invincible, so let's set the health to 0 and modify the damageable script so that an object can only die if the max health variable does not equal to 0. Nice! Also, don't forget to reference rigid bodies as root nodes. We did not modify the gun script, yet we have to. So 2 new variables set from the inspector and a new logic. If we hit something, let's hit the damn target passing these 2 parameters. We don't need the print function anymore, but we need to define a new function with 2 parameters. And it goes like this. Get the target, check if it is impactable, deal some damage and impact the object, else if it is damageable, just deal the damage. The only thing left is to check if it works. Shoot and look at that. We have officially implemented the bare bones of a shooting mechanic. Awesome! But as a genius game they once said, without VFX, this game looks ugly. So let's add a muzzle flash, I guess. For this we will need a GPU particles node and a light. Move them just at the tip of the gun and modify the particles. Set the amount to 1, lifetime to 0.1, FPS to 60, do not cast shadows, set GI mode to disabled, add a quad mesh, resize, add a material, set transparency to alpha, blend mode to add, cal mode to disabled, shading mode to unshaded, disable ambient light, use the muzzle flash texture as an albedo, disable shadows, use the particle billboard mode, keep scale, enable proximity fade and set the distance to 0.01. Ha! Add a new particles process material, set angle randomly from -180 to +180 degrees, disable gravity, set the scale curve points as I do it, and that's it for particles. You may tweak any of these settings to get the desired effect. Disable the particles node, set the light range to 6, attenuation to 2.5, intensity to the max, temperature to 2500, disable the bake mode and hide the light. We're going to control these 2 nodes from the gun script, so we will need references to them. Also a muzzle flash delay variable set from the inspector, a new private variable, and 2 new functions, one for enabling and the other for disabling shooting effects. On enable, we will set particles emitting to true and make the light flicker. On disable, we set particles emitting to false and hide the light. We enable the effects while shooting, else we disable them. Here we set muzzle flash time gun to 0 to prevent the initial delay. Let's test it, and the muzzle flash just works. Awesome! Muzzle flash looks great, but players expect bullet holes to appear whenever the gun shoots. For this we will instantiate this scene, which essentially is a decal plus some particles. First we need to preload the bullet hole scene and then create a function responsible for drawing a bullet hole. We instantiate the scene, change its positions, define a new basis for it, and change the rotation. We will call this function inside the shoot function like this. If we hit something, draw a bullet hole. One more thing, we will need to create a bullet hole script for emitting particles on ready and to delete itself after 10 seconds. Now, whenever we shoot, a nice bullet hole appears. Awesome! We don't have any sound effects yet. Let's fix that. Inside the gun scene, create an audio stream player 3D for the reloading sound, position it correctly, drag and drop a reloading SFX file, set attenuation model to logarithmic, unit size to 4, and modify the gun script. We will need a reference to the audio stream player, which will be called from the reload function. Here we have another audio file for shooting, let's add that too. Ctrl D to duplicate the audio stream player, rename it, drag and drop the shooting sound, set unit size to 10, and reposition. We need to modify the gun script, add a reference to the audio stream player, which will be enabled and disabled alongside the muzzle flash VFX. We went from no sound to this. Awesome! We can say that the shooting mechanic already looks convincing, but let's go to more advanced features and add some details like a trail to see where bullets travel. We'll need to add a gun tip to the gun scene, reposition, grab a reference to it, and add a new function for drawing a line. First, we define line variables, then we initialize the line mesh, initialize the cylinder mesh, initialize the line material, change the line direction, animate the line, and add it to the main scene. We just need to call this function here and pass these 3 parameters. As a result, we can see a trail where bullets are supposed to travel. But what's this? Line suggests that we have a problem, because currently we are shooting a ray from the player camera, but the gun tip is located at a different position. The solution is to shoot a ray from the player camera and then shoot the second ray from the gun tip in the direction of the first ray. We just need to modify the shoot function by adding these lines of code, which will change the result, and pass in the ray start parameter instead of the gun tip position. Now launch the game and we can see that the bullets don't go through walls anymore. Awesome! Well, this is another problem. Let's fix that. Modify the gun script so that there is a boolean to determine if a gun is clipping through a wall or something else. Then add a public function to change the isClipping value and make it only possible to shoot if the gun is not clipping. Now we need to create an area 3D inside the player camera, uncheck monitorable, remove collision layers and mask layer 3 to prevent clipping through objects too. Now create 2 collision shapes to roughly block out the shape of the gun. For the necessary logic, let's create a new script to prevent gun clipping. We will need to normal parameters to save the current position and the rotation of the gun. We also need counter clip parameters that will prevent clipping. Now let's make the gun node unique and grab a reference to it. We will prevent clipping on body entered signal and return to normal parameters on body exited signal. We also need to connect to these signals inside the ready function. That's it. If we test now, the gun cannot clip through walls and other objects, and cannot shoot while preventing clipping. Awesome! Problems fixed, but the shooting mechanic looks kind of unrealistic. So let's add some recoil to it. We will need to define a signal and a new parameter set from the inspector. We will emit the signal right at the end of the shoot function. We also need to modify the player camera script. Let's add a private parameter and a reference to the gun node. On ready, we will connect to the has just shot signal and get the recoil parameter from the gun script. We will create a new function which will add recoil each time the has just shot signal is emitted. Before we test it, let's add some random spray too, for even more realistic outcome, I guess. The randomness will depend on the accuracy of the gun set from the inspector, where 1 means totally accurate and 0 means totally inaccurate. We just need to add randomness and change the ray direction. Now we can test it and see that the gameplay experience has improved. This is the end of this video. Please like and subscribe. But before you go, I know some of you are smarter than me, and I am curious to see what you can change, improve or add to this project. Also, if you don't know how to create beautiful menus in Godot, check this video and thanks for watching.